On Tuesday of this week, grade 4s were eager to finally take the tomato plants that had survived our experiment outside to our school's community garden. Students were excited to be given an opportunity to work with community gardening experts and discuss with guests from Alberta Wellness the many benefits that having access to a community garden has provided them. Armed with 40 tomato plants, shovels, whiteboards, and measuring tape, our first group of students set out to our plot.
The first task was to determine how we would organize our plants in the plot so that each plant would have maximum amount of space. Students determined right away that we should measure the width and depth of the plot as a first step.
So here's 200.
With an opportunity to explore some of the other plots in our garden, students were quick to suggest that organizing our tomatoes in a grid would be their best bet. They identified two predominating ideas for how we should fit 40 plants into a grid.
I'm going to get the distance from here to right here, and then I'm going to do a little mark, and then I'm going to go, okay, exact same distance again to here. So I've got the whole depth. What do I have to divide it into? Arian?
4.
Awesome. One more time, Nikolai. How many rows did you want?
10. Mrs. Bailey standing, there was 4 rows of 10, and Grace kind of thought like, hey, why don't we just do 4 rows of 10?
8 down here, like 1, 2, 3, 4, 5, 6, 7, 8.
Yeah.
And then you could have 5 across. So you could count by 5s, and you could go 5, 10, 15, 20, 25, 30, 35, 40, and then you could figure out exactly what you need for our row.
Here is each spot.
Miss Park?
Like here's 5 by 8, 5 by 8 here, and 4 by 10 here. This one would be better for width.
The next step was to determine the width and depth of each individual square on the grid, whether the students had decided to organize the plants in a 5 by 8 plot or a 4 by 10 plot.
118 divided by 4, because we want 4 rows. Okay. And that equals 29, remainder of 2.
32.
Yeah.
So that's 4.
With 2 left over.
With 2 left over. That's 25. How many 8s then?
So 8, 16, 24. We just did
24,
that.
so that's
remainder 1.
3, 1.
So 43 remainder 1.
So here's my question, guys. How do we figure out where those remainders go?
You can break them open into this.
Okay, so how would we do that? What would we need to add to 118 and what would we need to add to 345?
We add 10.
Yeah, we had to have tenths and hundredths, right? So how did we draw that? What did we write at the end of the numbers?
0 first. You're not sure you're going to need more to 0.
So what did you figure out?
So down here is practically like our hypothesis because we've got remainders and you can't have remainders, so you have to add 0.00 at the end. So up here, we did 345.00 divided by 10, which equaled 34.5.
So the boxes, the squares across would be 29.5 centimeters
Each? Okay.
each. And the ones going up, across is 34.5 centimeters.
Our morning flew, and by the time our first classes had ended, calculations were complete and we were ready for planting. We took a minute to review what the first group had discovered with the second group of students.
So what's our next equation now to figure out how much width each plant gets? What's our next equation going to be? Owen.
345 divided by
Before heading back outside, students collected the containers with our fully decomposed specimens that had been buried in soil from the science lab from our previous experiment. This rich decomposed soil would be mixed in with the dirt in the plot, adding rich nutrients for our plants.
Our first step was to loosen the soil for our plants, adding the compost soil and mixing it in as we went.
Goodbye, banana. Goodbye, orange. Goodbye, potato. Goodbye, Goodbye, grapefruit. Bye, avocado.
Next, we used the string and measuring tape again to outline a 4 by 10 plot with equal space for each of our plants. So we've got our 4 sections now, 1, 2, 3, 4, and now we have to do how many this way? 10. Finally, we were ready to plant. Thank goodness for the expertise of our local community gardeners as they showed us how to transplant the plant from the pot into the soil.
So
what you need to do is you kind of wiggle. This is what my mom taught me, right? You wiggle and because the dirt's a little wet, it's better when it's drier, but you're just going to put your hand on here and cradle it. And you want to keep the root ball together. So you know what a root ball is?
Yeah, okay.
Like this, okay? And then you want to hold it, stabilize it.
I'm having trouble myself.
Oh, give me a hand. Okay, guys, hold it up.
This is failing.
We call this staking it, so see how slowly.
That's okay.
Our second group of students were able to return in the afternoon to plant the rest of our plants before leaving for the day.
Students blended deep mathematical understanding with scientific exploration in order to create a beautiful garden full of tomato plants.